Expired certificates represent the leading cause of preventable downtime in microservice architectures. When a root trust anchor vanishes, encrypted traffic halts instantly, triggering cascading failures that monitoring systems often misdiagnose as network latency or database connection timeouts. Cert-Manager eliminates this risk by treating identities as dynamic Kubernetes resources. It acts as a specialized controller that automates the entire lifecycle, from generation and validation to the rotation of secrets, without requiring any manual human intervention or external scripts. Kubernetes uses custom resource definitions to extend its native application programming interface. Cert-Manager introduces objects like issuers and certificates, allowing developers to manage transport layer security configurations using the same YAML syntax and declarative patterns applied to deployments and services. Scope defines the operational boundary for certificate authorities. A standard issuer is restricted to a single namespace, ideal for isolated environments. In contrast, a cluster issuer provides a global resource available to every namespace within the entire cluster, simplifying multi-tenant management.
Deployment begins by adding the official Jetstack Helm repository. Use the repository add command, followed by an update to ensure your local cache contains the latest chart versions. This repository is the trusted source for all stable Cert-Manager releases. Isolating infrastructure components is a security best practice. Create a dedicated namespace named Cert-Manager to house the controller, the injector, and the webhook pods. This separation prevents application-level errors from interfering with the critical certificate management process. Execute the Helm install command, specifying the namespace and the version. Set the Install Custom Resource Definitions flag to true. This ensures the necessary schemas for issuers and certificates are registered with the Kubernetes Application Programming Interface server during the installation phase. Validate the installation by querying the pods in the Cert-Manager namespace. All three components must show a running status. The webhook pod is particularly vital as it validates the configuration of every Cert-Manager resource you will later apply to the cluster.
Most automated certificates use the Automated Certificate Management Environment Protocol. This standard allows Cert-Manager to communicate with authorities like Let's Encrypt. It proves domain ownership through challenges, removing the need for manual identity verification steps or email-based approvals. Always start with the Let's Encrypt staging environment. It uses the same protocol as production, but has much higher rate limits. This allows you to debug your challenge solver logic without risking a lockout from the production certificate authority during configuration errors. The Hypertext Transfer Protocol challenge is the simplest to configure. Cert-Manager spins up a temporary solver pod and modifies your ingress to route a specific path to it. Let's Encrypt then verifies that the file exists at your domain on port 80. The domain name system challenge proves ownership by placing a temporary text record in your DNS zone. This method is essential for issuing wildcard certificates and is highly secure because it does not require opening any inbound ports to your internal cluster.
To automate domain name system challenges, Cert-Manager requires access to your cloud provider. Store your application programming interface tokens or service account keys in a Kubernetes secret. Ensure the secret is located in the same namespace as the issuer resource to grant proper access. An issuer YAML defines the certificate authority and the challenge mechanism. Specify the ACME server URL, an email address for expiry notifications, and the private key secret name. Include a solvers block that defines whether you are using HTTP or domain name system validation. Apply the issuer configuration using the kubectl apply command. Once applied, Cert-Manager registers an account with the certificate authority. This account is the identity used for all subsequent certificate requests originating from this specific issuer or cluster issuer. The certificate resource is your request for a specific identity. It defines the secret name where the final key pair will be stored, the common name, and any subject alternative names. It also references the issuer that should handle the signing process.
Modern security standards favor elliptic curve cryptography. In your certificate specification, you can define the key size and algorithm. Using ED 25519
or ECDSA P256, provides higher security with smaller key sizes compared to traditional RSA. When a certificate resource is created, Cert-Manager generates a certificate request. This triggers an order with the ACME provider. The order tracks the progress of the challenges and ensures the final certificate is only issued once all domain validations are successfully completed. Once issued, the certificate and private key are stored in a Kubernetes secret. Any pod requiring transport layer security can mount this secret as a volume or reference it in an Ingress resource. The controller ensures the secret is always up to date with the latest valid data. The Ingress Shim is a powerful feature that monitors Ingress resources for specific annotations. By adding the Cert-Manager issuer annotation to an Ingress, the controller automatically creates the corresponding certificate resource for you, streamlining the deployment of new encrypted services.
For the Ingress Shim to work, you must define a transport layer security block within the Ingress specification. Specify the hosts and the secret name where the certificate should be stored. Cert-Manager will match these details to fulfill the request through your defined issuer. The modern Kubernetes Gateway application programming interface is also supported. Cert-Manager can manage certificates for gateways using policy attachment. This allows for more granular control over shared infrastructure, where multiple teams might use a single entry point with different security requirements. Cert-Manager monitors the expiry date of every managed certificate. By default, it begins the renewal process 30 days before expiration. This window provides ample time to solve challenges and rotate the secret, ensuring that the service never encounters an expired identity. The Cert-Manager command line tool, known as CM Control, provides advanced inspection capabilities. Use it to check the status of certificates, manually trigger renewals, or inspect the health of the controller. It is an essential tool for any system analyst managing large-scale clusters.
Failures often occur during the challenge phase. Inspect the challenge resource to see the status of the validation. Common issues include domain name system propagation delays or firewall rules blocking port 80 for HTTP challenges. The status message field usually contains the exact error from the CA. Kubernetes events provide a chronological log of Cert-Manager actions. Use describe commands on your certificate or order resources to see when challenges were started, when the key was generated, and when the secret was updated. These events are the first place to look when debugging issuance. Restrict access to Cert-Manager resources using role-based access control. Only cluster administrators should be able to create cluster issuers, while application developers should be limited to creating certificate resources within their own namespaces. This follows the principle of least privilege in your DevOps workflow. For internal services, use the Trust Manager extension. It allows you to distribute custom certificate authority bundles across all namespaces automatically. This ensures that internal microservices can verify each other's identities without relying on public certificate authorities for private, high-speed communication.
Upgrading Cert-Manager is handled via Helm. Always review the release notes for breaking changes in custom resource definition schemas. Because the controller is separate from the certificates it manages, existing transport layer security connections remain active even while the Cert-Manager pods are being restarted. Automated certificate management is a cornerstone of a zero-trust architecture. By removing manual steps and shortening certificate lifetimes, you reduce the impact of potential key compromises and ensure your infrastructure remains resilient against the inevitable failures of manual identity rotation.